Group 34 final report. Our question of interest: which factors influence hotel reservation cancellations? Our analysis aims to identify key factors and determinants that lead to the cancellation of hotel bookings. Our motivation: our group shares an interest in economics and finance. So our first thought when we found the hotel data was that we wanted to understand consumer habits related to hotel bookings. The answer to our question of interest can prove to be valuable for hotels as it aims to identify the customer segments and economic conditions most associated with reservation cancellations. Understanding these patterns can enable hotels to strategically adjust their pricing and marketing efforts. A description of our data set, and this data set takes an existing data set, hotel bookings demand, from Science Direct, where each row is a hotel booking. Each observation represents a distinct hotel reservation, and within those observations, we have information about the person booking the hotel being booked, economic conditions at the time of booking, and altogether we have over 119,000 observations. Our variables of interest is canceled. That's our response variable. It's a binary variable, 1 if the reservation was canceled, 0 if it was not. And some other important variables, or at least that we initially thought were important to our model, or our question. ADR, the hotel's average daily rate, how much money are they making a day at the time of booking? Lead time, the number of days between booking and the reservation date. Deposit type, whether or not it's no deposit, non-refundable, or refundable. Arrival date, week number. On a 52-week year period, it's the week in which they arrive. Previous cancellations, the number of previous bookings that were canceled by the customer prior to the current booking.
All right, now moving on to some EDA. The first thing we did was find the counts and proportions for our binary response variable. You can see that about 75,000 reservations in our data set were not canceled, whereas about 44,000 were. It's about 63% and 37% respectively. And we were pretty happy with this because this gave us a large number of observations for each result of the response variable to work with. Moving on to some box plots. This is one of the most interesting ones that we found. It's a box plot of lead time compared with cancellation status. And you can see that both the median and the IQR for non-canceled reservations is lower, meaning that people booked those reservations closer to the actual day that the reservation is for. Next, we have this one. This one's interesting. Hotel CPI, which is an economic measure. It's the consumer price index for hotels. It's interesting to see that while the IQRs are similar, the median is noticeably higher when a reservation was canceled. And this does make sense because when the price is higher, it makes sense that it would be canceled. Next is ADR. This one's interesting because we really thought this one would be different than this, but actually it seems like the cancellation status is pretty similar with different ADR values, or rather the ADR values are similar with cancellation statuses. So that one might be important and might not be, and definitely warrants further investigation. These help us answer our question of interest because they give us a good jumping off point. We can see that lead time and hotel CPI are clearly, they do have an effect on cancellation status, whereas ADR and fuel prices may or may not. We'll have to investigate that more.
So in building our logistic regression and LDA models, we initially included 10 predictors. However, after conducting walled and likelihood ratio tests to our logistic regression model, we determined that the predictors CPI hotels and the 2 dummy variables, no deposit and group, were insignificant to the model. However, with the walled and likelihood ratio test, we were able to add 3 new predictors. Therefore, all 13 predictors in this logistic regression model were deemed significant to the model. For our ridge and lasso regression, and we included 8 variables, and in our ridge regression, we were all left with all 8 predictors because ridge regression always keeps the predictors no matter what. However, with lasso regression, we were left with 4 predictors because 4 of the 8 predictors coefficients were truly 0 with our best lambda value. Therefore, After ridge and lasso regression, the important predictors found were ADR, adults, children, and lead time. For our classification tree, we used 13 variables to build the tree. However, we found that deposit type was the most important predictor, followed by lead time, followed by previous cancellations, consumer tips, and fuel prices. And in building our random forest, we include the same 13 variables. And we found that the most important variables were deposit type, arrival date, lead time, ADR, and the predictor disinc. So one comparison we have between all the models was that certain predictors such as ADR and lead time were found by all models to be the most important and significant predictors. However, there are some contrasts. One big contrast was the differing number of variables input to each model. For example, logistic and LDA models used 10 predictors, ridge and lasso models used 8, and the trees used 13. There was also differing test error rates between each model. For instance, the LDA test error rate was higher than a logistic regression. The random forest had a lower test error rate than the prune tree, and the lasso had a higher test error rate than the ridge regression. And part of this is due to certain assumptions that weren't met in order for these models to work. For instance, LDA failed to meet its multivariate normality assumption, therefore resulting in a higher test error rate.
Moving on to some interesting findings, we saw earlier that deposit type was one of our most important predictors, but what the model actually found was that the non-refundable deposit types predicted a canceled reservation, which is kind of the opposite of what we would have thought initially, where you would have thought that a deposit being non-refundable would have encouraged people to not cancel it and actually show up. Additionally, we found that arrival week was a very important predictor, which was surprising just because looking at the variable description, we didn't think that when the time during the year that a reservation was made would be a very important predictor to whether or not it's canceled, but apparently it was. Additionally, we found that being a repeated guest was not a very important predictor, which was interesting because initially we thought that maybe repeated guests would be less likely to cancel their reservations, but that was not the case. And finally, we found that economic indicators such as CPI and gas prices had a moderate importance in predicting canceled reservations. So they weren't wholly insignificant, but they were not as significant as something like deposit type. So in conclusion, hotel cancellations were able to be predicted with very high accuracy. Our random forest model was able to do it with 93% accuracy. And then we have the most important predictors that we touched on earlier. So all in all, we felt that we were successfully able to answer our questions of interest.